The topic of this video is analyzing the graph of a rational function. This is a continuation of the previous video. Okay, so in our previous video we completed steps 1, 2, and 3. We're now moving on to steps 4, 5, and 6. Let's talk about step 4, vertical asymptotes. For step 4 we use the reduced R to find the vertical asymptotes. Graph each vertical asymptote using a dashed line. Determine the behavior for the graph of R on either side of each vertical asymptote. Well, for this particular problem, we didn't have any matching factors top and bottom, so we were not able to reduce. So our original function is our reduced function. They are one and the same. So we're going to use our reduced denominator polynomial to find the vertical asymptotes. So we set the denominator equal to 0. Then by the zero product property, x plus 3 equals 0, x minus 2 equals 0. And solving each equation gives us two vertical asymptotes, x equals -3 and x equals 2. So our vertical asymptotes are x equals -3 and x equals 2. How many factors produced a -3 result? Just one. How many factors produced a +2 result? Just one. Those are both odd. So what that means is that both of our vertical asymptotes will have the curve approaching them in opposite directions. It will either be up on the left, down on the right, or down on the left, up on the right. We'll have to decide which one it is when we get more information at a future point. Okay, that moves us on to step 5, horizontal or oblique asymptote. So we have our function here, y equals x squared over x squared plus x minus 6. To find the horizontal or oblique asymptote, we start with the degree of the numerator polynomial and the degree of the denominator polynomial. Both of these are degree 2. And because the numerator degree and the denominator degree are equal, this means we're going to have a horizontal asymptote, y equals b, where b is the ratio of the highest degree term coefficients. The reason why the top was degree 2 was because of this x squared, and it has a coefficient of 1. The reason why the bottom was degree 2 was because of this x squared, and it has a coefficient of 1. So for this problem, b is found by dividing those two numbers, 1 divided by 1, which is 1. So we get the horizontal asymptote y equals 1. Horizontal asymptote y equals 1. Okay, the next thing we have to check for is an intersection. Does our curve intersect our horizontal asymptote of y equals 1? To find that out, you're just going to write your curve using your reduced r of x, which, keep in mind for this problem, happens to be the original one because we could not reduce it. So we use our original equation and the equation of our horizontal asymptote. They both start with y equals, and then we set them equal to each other. So this gives us x squared over x squared plus x minus 6 equals 1. Now 1 can be written as 1 over 1, and then this is a proportion, so I can set the cross multiples equal to each other. We'll take those two things and multiply them, and set that equal to these two things when we multiply them. So on one side of our equation, we're going to have x squared times 1. On the other side, we're going to have x squared plus x minus 6 times 1. And then the equal sign comes down in between them. Now anything times 1 is itself, so this just gives me x squared equals x squared plus x minus 6. Subtracting x squared on both sides gives me 0 equals x minus 6. Adding 6 to both sides gives me 6 equals x. So there is going to be an intersection in this problem. And the x-coordinate of that intersection is 6. All we have to do now is find the y-coordinate of the intersection, and we do that by plugging into our function. So we know that y equals x squared over the denominator x squared plus x minus 6. If x was equal to 6, then we would have y equals 6 squared over 6 squared plus 6 minus 6, which is 36 over 36 plus 6 minus 6, which is 36 over plus 6 minus 6 cancel, so my denominator is 36, and 36 divided by 36 is 1. So when x equals 6, y equals 1, and we have now found the location where our curve will intersect the horizontal asymptote. And there's only one location, which means this is the only point where our curve can intersect the horizontal asymptote. All right, we will continue on with our next part, which is part 6 in our next video.